Hello, everyone. I am Anil Kumar from Toronto, Canada. I'm glad that you joined for our trigonometry class. I'd like you to introduce yourself one by one. Akshat, can you begin?
Yes, sir. Hi, I'm Acute from Toronto, Canada, and I'm here again to continue expanding my knowledge of trigonometry.
Thank you. How about you, Krishiv?
I'm Krishav Gopal. I'm in year 9 in London, UK, and I'm improving my knowledge in trigonometry.
Great. Samita, can you introduce yourself, please?
Hi, my name is Samhita Korkonda. I'm from Seattle and I'm here to get better at trigonometry.
Great. So we have one from UK, one from US, and one from, well, both of us from Canada. That's great. So let's begin with our session today. We'll try to see how do we solve simple trigonometric equations. Well, Samita, thanks for sharing some questions. I'll take those questions up. And mainly because of your questions, I have today selected this particular topic. Now, both Krishiv and Akshat, they are not very familiar with trigonometry. They only know a bit since, we just began with a couple of classes. So I'll first teach you the basic concepts to solve the trigonometric equations, and then I'll take up the examples which you have shared with me, okay? So let me share a lesson which I prepared for you for today. Uh, where? Hmm. Okay, so can you see the screen of mine?
Yeah.
Yes, sir.
Angles in coordinate plane, and that's the topic for today. So when we solve a trigonometric equation, we can actually have more than one solution, right? Reason is very simple, right? So for a trigonometric equation, um, why do we have more than one solution? Can any one of you answer that question?
Because values on the unit circle may overlap.
Okay. You see a sine wave, for example, right? When we solve a trigonometric equation, we are trying to find a value for which the two are related. So if I draw a horizontal line, which is the value of the function, right? So it crosses at many points. You can see that, correct? All those become the solution of our equation. Perfect. That is why we do get many solutions for a trigonometric equation, right? Now, many times what happens is that we are only interested in a limited set of solutions. Mainly, uh, normally when we begin with, we try to figure out what is the solution between an interval where the angle theta, or sometimes we say the variable x, independent variable x, is between 0 to 360 degrees, right? Those of you who are working in radians, they will say from 0 to 2 pi radians, correct? So that is one full circle, as you said, a unit circle, right? So normally we are looking at the unit circle. That means we are looking into the angle from 0 to 360 degrees or from 0 to 2 pi, correct? So within that, we look for solutions, and then we know general solution could be all the co-terminal angles, which you can get by adding 360 degrees, or the period of the trigonometric function if the case is different. Is that clear to you? Right? So that is the base. Now here, we are looking into strategies to solve trigonometric equations with given restrictions. So we'll restrict our domain, and most of the cases, we are restricting our domain to this interval from 0 to 360 degree, or you can say one unit circle. Is that okay? So we'll limit ourselves to that unit circle. So unit circle may be a new term for Krishiv and Akshat, but soon you will understand what I'm trying to say, okay? So here is the strategy with us. So Akshat, can you read this small print which is written, some bullets?
Yes, sir. Strategy. In the given domain, we may have more than one solution. Simplify equation to isolate trigonometric ratio. From the sign, identify quadrants for principal angle x. Solve for reference-related acute angle alpha. Find coterminal angles and identify quadrants for all the solutions.
Correct. That is the base for our solution to any trigonometric equation, right? So we'll look into the domain. Example number one. Krishiv, can you please read example?
Solve trigonometric equations in the interval 0 degree to x to 360 degrees.
Where x is greater than equal to 0 degrees and less than equals to 360 degrees. That means one full cycle of any trigonometric function. So solve the following equations given your answer is give your answer in the interval from 0 to 360 degree. So we have very simple equations here, and we will see how do we solve them. So the very first one is sine theta is equals to 0.9975. Well, a very simple solution is that you can use your calculator and find what inverse is, right? So theta is sine inverse of 0.9975. Once you do that, you will get one solution. However, within this interval of 0 to 360 degrees, you know that there are two solutions because sine value is positive, correct? How do you get the second solution? This is the first thing we have to understand. So, well, we know the cast rule, right? So the cast rule clearly is that all are positive in quadrant 1, sine is positive in quadrant 2, tan in 3, and cosine is positive in quadrant 4. Now, since in this particular case, sine has a positive value, we are looking for two solutions. One will be in quadrant 1, the other one will be in quadrant 2, correct? So first thing is, from the given equation, identify the quadrants in which the solution may lie. Since sine is positive, we have two solutions, quadrant 1 and quadrant 2, right? Now, to find the solution, what we do here is, so first is, we cannot simplify this further because this equation sine theta is simplest form, correct? So you understand the first thing, right? Then from the sign, identify the quadrants. We identify the quadrants. Quadrants are 1 and 2. And then we are going to use the reference angle to really find both the solutions. So what we do normally is that we find the reference angle. Reference angle is always less than 90 degrees. That means the trigonometric ratio has to be positive, correct? Well, in this case, we are given a positive ratio, but even if it is not given a positive ratio, as in example 3, which is a negative ratio, we'll find the reference acute angle by finding the inverse of the function in quadrant 1 using the positive value. So what we do here is, since we know that sine theta's solution lies between 0 to 360 degree and sine is positive in quadrant 1 and 2, we know that there are two solutions, right? So we use the reference angle sine alpha equals to 0.9975. And therefore, alpha will be sine inverse of 0.9975. That gives us 85.94 degrees, or we round it to whole number, 86 degrees. So that becomes the reference acute angle. Now we know that the reference acute angle alpha, which is the diagram shown here, is 86 degrees. The other solution should be what? The other solution will be 180 minus alpha, correct? And so we find the other solution also, which will be 180 minus alpha, or 94 degrees in this particular case, since alpha is 86 degrees. You get the idea. So we got both the solutions using the reference acute angle. So therefore, as you can see, we need to look into this quadrants, right? The cast rule to figure out where the solutions may lie. Second is we'll take help of related acute angle, and then we'll use our common sense to find both the solutions. Clear? Now let's take up the second example, which in this case is 1 minus 2 tan theta equals to 0. So here is example number 2, 1 minus 2 tan theta equals to 0, and theta being between 0 to 360 degrees. We'll now simplify the equation, writing all the terms with theta on one side. So we just rearrange. So 1 is equals to 2 tan theta equals to half, which is 0.5, right? So now we have a simplest form of the trigonometric equation. We are looking for tan theta equals to half. Where is tan theta positive? In which quadrants?
1 and 3.
1 and 3. So we'll draw this line and say, well, we do have two solutions. One lies in quadrant 1, the other one in 3. Let's find the related acute angle. Well, this time also it's a positive angle. We'll do theta. We'll say tan alpha equals to 0.5, alpha being tan inverse of 0.5. Using calculator, we find the value, 26.5, right? Well, it should have been rounded to 26.6, strictly speaking, but I wrote 26.5. We'll go with this value. Well, so now, if 26.5 is my related acute angle, then one of the solution is 26.5. The other one will be 180 plus 26.5, correct? I rounded it to 26.6 later, so which is the right thing. let me change this, okay? Because it was actually 26.56, so it rounds higher, right? So we get two solutions, 26.6 and 206.6 degrees. Is that clear to you?
Yes, sir.
Right? Clear? Krishiv, is this clear to you?
Yes, sir.
Very good. Now let's take the third example. This time the example is different since we are looking into the reciprocal of our or secondary trigonometric ratio, which is cosecant. So we are saying cosecant theta is minus 3.2360. Now you know cosecant is what? Cosecant is the reciprocal of sine, correct? So we could write this equation as sine theta equals to minus of 1 over 3.2360, correct? Because calculator only provides us primary trigonometric ratios and not the secondary. So to find the value of related acute angle, it is important to write every trigonometric equation in terms of its primary trigonometric ratios. So sine theta equals to minus 1 over that, and we know sine is negative, means in which quadrant are we looking into? The solution lies in which quadrants?
3 and 4.
3 and 4. So that is what I've done here, 3 and 4. Now I need to find the related acute angle. And to find the related acute angle, do you see I have dropped the negative sign? I'm writing sine alpha equals to a positive value of 1 over 3.25, and I get angle as 18 degrees using my calculator. So I know that related acute angle alpha, which has to be between 0 to 90, is 18 degrees, and the two solutions should be what? Well, one of them, as shown here by arrows, is 180 plus alpha, means 180 plus 18. The other one being 360 minus alpha, right? So the other one is 360 minus alpha, which is equal to, as shown here in the calculations, 180 plus 18 is 198, 360 minus 18 is 342. So those become the two solutions in the given domain of 0 to 360 degrees. Is that clear to you? Correct. Another example, example number 4. So Samita, can you please read the example number 4?
The problem or the words?
Solution.
Okay, solution 4.
Hmm.
Isolate sine x, that one, right?
Yes. So 1
Isolate
plus 2 sine x equals to 0. We need to find the solution of theta between 0 to 360 degrees. We'll isolate the trigonometric ratio 2 sine x minus 1 on the other side divided by 2. Sine x equals to minus half. Correct? Now, Samita, what are you going to do to solve this equation sine x equals to minus half? Tell me.
You can look at the unit, well, we use unit circle. You can look
Yes.
at the unit circle and see where sine is negative. So in this case, sine is negative in quadrant 4 and 3. So you have to see if any y values there are negative in
Perfect.
one half.
Perfect. Unit circle is always used when you're looking only for exact solutions. In previous two cases, you could not use the unit circle since you don't know the exact values of those point decimal values, correct? But for half, you know, we have alpha as 60 degrees, and that is where sine x is half, correct? So in this particular case, sine alpha equals to half. That means alpha is sine inverse of half, which is using your special triangle, right? You could use special triangle or your unit circle. You know alpha is 60 degrees, or use your calculator. So we know now the related acute angle is 60 degrees. Well, in many books, this related acute angle, which I'm using the symbol alpha, is written as beta, right? Let's be very clear about it. Most of the books use beta. I have used alpha as my related acute angle, okay? So the two solutions are 180 plus alpha for the quadrant 3, 360 minus alpha for quadrant 4, 180 plus 60 is 240, 360 minus 60 is 300. So those are the two solutions which you get for this particular question, correct? Now example number 5 is square root of 3 minus 2 cos x equals to 0, where theta is between 0 to 360 degrees. First step, isolate the trigonometric ratio cosecant x. So when you do this algebra, you get cos x is square root 3 over 2, a positive value. That means again, we're looking for two solutions. One, in which quadrant? Which are the two quadrants? Cosine is positive in
1 and 4.
1 and 4. So you draw this and say 1 and 4. Let's find the related acute angle. Now, when you try to find the acute angle, right, cos alpha is square root 3 over 2. So alpha is 30 degrees. You could use your circle, right, unit circle, or a special triangle to find the exact value of theta in this particular case, right? In case you're using radians, then you know this is pi by 6, correct? So you could write pi by 6 as your solution. So for Samita, because they work in radians, she will write pi by 6 here. And so we get one of these values. But both the values, which will be, well, since one of them is quadrant 1 itself, one of the solutions is pi by 6 itself. The other one is 2 pi minus pi by 6, correct? 2 pi minus pi by 6, correct? Right? And then you go, this is like 11 pi by 6, 12 minus 1, which is 11 pi by 6, correct? So that will be the other solution within the domain from 0 to 2 pi. Is that clear to you? That is how you could solve this particular question. So likewise, you can solve all the questions by just identifying the trigonometric ratio in which quadrants it is positive or negative. The last solution before us is 1 minus square root of 3 tan alpha equals to 2. Then when you rearrange it, you get tan x equals to minus 1 over square root 3. Here also, you could use a special triangle, right? And find out the answer. So when you do your special triangle, you know alpha should be equal to 30 degrees or pi by 6, correct? Since tan is negative, we are looking for the two quadrants to be quadrant 2 and 4. Acute angle being 30 degrees, and therefore the solution will be the principal angle 180 minus 30 and 360 minus 30, and we get our solution. Do you see these simple steps to follow over and over again to answer the simple equations as we did, right? Is that clear to you, right? Great.
Yes, sir.
So these are the basic steps which we are going to follow to answer all such questions, right? Now, we could have many other questions similar to this with different domains to discuss. Now, here is another very interesting example where I'm changing the domain. So one of these examples include the angle, which is like 2 theta. Do you see that? So question number 7. Samita, can you please read question number 7?
Yeah. Change domain for 2 theta.
Hmm.
Solution is in quadrant 1 and 3 since sine
Correct.
is
So let me read the question once again. So in this particular thing, we have to solve for the equation 2 sine 2 theta equals to square root 3. So it is not just theta, it is 2 theta. Do you see that? And the domain is where theta is between 0 to 360 degree. Do you see that? Theta is between 0 to 360 degree. Now, if you land up in such a situation, well, you could first rearrange it. You know, sine 2 theta is square root 3 over 2, correct? Right? And you can write your acute angle alpha as square root 3 over 2, just as we did earlier. And you know from special triangle, unit circle, or your calculator that in this case, the related acute angle alpha is 60 degrees, right? Or square root 3 over 2. Now, let's get back to the other possible solutions within the given domain from 0 to 360 degrees. Now remember, we are not talking about just theta. The argument is 2 theta, right? So if theta is between 0 to 360 degrees, then 2 theta will be in the interval from 0 to 720 degrees. We have to now change the domain based on our argument. So instead of theta being from 0 to 360, we'll work on 2 theta being from 0 to 720. So in our case, now we know alpha, right? But the other possible values which we need to figure out will be what? Will be, since sine is positive in this particular case, we're looking for all the solutions in quadrant 1 and in quadrant 2. Coterminal angles in these two quadrants, correct? We know one of the related acute angle and this angle 60 degrees as shown here. Now the other angle will be 180 minus 60, correct? 180 minus 60. But since our domain has increased up to 720, we will now add 360 and 360 and get the other two possible values, correct? So now 2 theta, which is what we are looking into, its domain is from 0 to 720, will be now 60, 120, 420, 480. How did we get 420 and 480? We added 360 to 60 and 120. You get the idea. Samita,
Yes,
I'd
sir.
like you to read all. This is given in blue here.
okay. All of it.
Yeah, all of it, one by one.
Change domain for 2
2
2
theta.
theta. Solution is in quadrant 1 and quadrant 2 Since sine is positive, solve for related angle alpha, write all four coterminal angles in modified domain to theta. And then the axis.
You get the idea? So here, once you get all the solutions of 2 theta, which is 60, 120, 420, and 480, theta will be half of these. Divide them each by 2 to get your final solution, and your answer is theta equals to 30 degrees, 60 degrees, 210 degrees, and 240 degrees. Is that clear to you?
Yes.
Yes.
You
Yes,
get
sir.
the idea? So the trigonometric equations become slightly more complicated if we change the argument, right? So the idea here is, if you're solving a general equation which is of the form f of x equals to a times sine k x minus p plus q, this is the general equation, modified or transformed equation of sine. In that case, do you see that domain? The argument is k times x minus p. So if you are given theta between 0 to 360 degrees, first thing you should do is take away p, right? X minus p from each side. So you get 0 degrees minus p is less than equal to theta minus p, which is less than 360 minus p. And then you have to multiply by k to get the right domain to work in. You get the idea? So you have to modify the domain first to see all possible solutions, right? So now you understand. You're looking into the coterminal angles in the same quadrants, correct? Let me take another example, and that's going to be our last example before we take up the questions from Samita, okay? So, Akshay, can you please read question number 8?
Yes, sir. Cos of theta plus 20 degrees equals to 0.6428.
Hmm.
So
Theta
your
is between
restriction would
0
be
to
the,
360 degrees.
yeah.
First step is to modify the domain for possible solutions. Now the domain is for theta plus 20 degrees, right? Theta plus 20 degrees. So we'll actually change alpha to theta plus 20 degrees, but let's work on the domain of theta plus 20. We'll add 20 to each term, right? That is how you solve inequalities. So we get theta plus 20 degrees should be between 20 degrees and 360 plus 20. I forgot to write 360 plus 20 here. That means 380 degrees, correct? That is our now domain. Now, first step first, cosine is positive. That means we are looking for solutions in quadrant 1 and in quadrant 4. Clear? Now, related acute angle is always positive. We are taking the positive value 0.6428 using the calculator to find alpha as cos inverse of 0.6428, and we get alpha as 50 degrees, rounded to a whole number, correct? So we know this angle alpha here is 50 degrees, right? So 1, since we have this circle, we know 50 degrees, and we know the angle should be greater than 20. Since 50 is greater than 20, it is in our domain. Do you get the idea, right? The other value will be 360 minus 50, correct? So the other value is 360 minus 50, which is 310 degrees. And 310 degrees is also within our domain. It is less than 380 degrees. So therefore, those are the two possible values for theta plus 2 theta, theta plus 20 degrees, sorry, theta plus 20 degrees. So that means we can write that theta plus 20 degrees is equal to 50, or we can also rearrange this and write theta is 50 minus 20, which gives us theta as 30 degrees, correct? The coterminal angle will be theta plus 2 theta is equals to 310 degrees, which is 360 minus 50, right? And then I take away 20 from 310 to get the other answer, which is 290 degrees. So those become the two solutions for the given case. Is this clear to you?
Sir?
Is it clear, Krishna?
Yes, sir.
Sir,
Slightly complicated. Yes, Akshay.
sir, I just wanted to confirm. You took away 20 because in the initial question, the question gave theta plus 20 degrees, right, sir?
Yes, sir. Because we want
Okay.
only theta value, right?
Yeah.
Theta plus 20 is the angle which we found to be as 50. So theta is 50 minus 20. The other angle was 360 minus 50, which was 310, right? So theta plus 2 theta 20 was 310. So theta was 310 minus 210, which gave us 290. Is that clear? Correct? Okay. So Samita, can you now tell me what are your questions? We'll answer your questions now.
Yeah, let's see. So first one is sine of x over 2 is equal to 0.
Sine x over 2 equals to 0. And you want the solution where x is between what?
Um, it doesn't say here, but it's 0 to 360.
It doesn't say. We're restricted to 0 to 2 pi for the time being. Is that okay?
Mhm.
No problem. So, because if it is a general solution, I can give you the general solution also. We can do that also, right? No problem. Since it was x by 2, you see it is kind of a modified solution, right? So first step first, we have to divide each by 2 to find the real domain for our answer set. So if I divide, I get that x by 2 should be between 0 to pi by 2, correct? Is that clear to you? 2 pi pi, right? So that means x by 2 is between 0 and pi. Is that clear to you? So we're looking for solutions between 0 to pi. Is that clear? Now, since sine of x by 2 is equals to 0, what could be alpha equals to? We say sine alpha equals to 0. So alpha is equals to 0, right? Sine 0 is 0, correct? Now, for sine alpha to be 0, now the other angle will be pi, correct? Is that clear?
Sir,
Yes.
sir, pi in this case would be 180, right, sir?
180, 180. Yeah. For you, pi 180, correct. So, Krishav, we are looking for a solution from 0 to 2 pi. That really means 0 to 360 degrees. And sine, is 0. For 0, pi, 2 pi, rather n pi. In general, it will be n pi, correct? That is the general solution. Is that clear? N pi, where n belongs to set of natural numbers. Is that okay? Well, we can say set of integers. That is better. Z. Normally, most of the time, we write Z set of integers, right? Plus, minus, and including 0. Well, so the general solution is n pi. So we say x by 2 is equal to n pi, and therefore x is equals to 2n pi. Is that clear to you? Where n is equals to n is set of integers. Is that clear? That becomes the solution for the given question. Samita, is this absolutely clear to you?
Yeah, it's clear, sir.
Okay, next question, please. I can't hear you. You are on mute.
It is 2 sine x
Okay, let me rewrite here. Let's use some pen. Yeah, 2 sine x.
plus cos x
Yeah,
is equal to 0.
right. So
And
first step, and continue. Yes, and
interval is 0 to 2 pi.
0 to that means 0 to 360 degrees. Well, it is only x. Fine, that's great. So first step is we have to rearrange this equation, write it in the form of one trigonometric ratio so that you can use the calculator and figure it out. So how could you do it? Samita, can you help me solve this equation?
I mean, I was going to suggest maybe making it a Pythagorean identity, but there's no squared, so you can't do that.
Simple step I'll teach you. Take cos x to the other side. So you get 2 sine x equals to minus cos x. Is that clear to you?
Yeah.
Now divide by cos x, both sides. So this side is minus 1. And what is the left side? 2 tan x. 2 tan x.
Oh.
So we have 2 tan x equals to minus 1. And that gives you tan x equals to minus half. Is that clear to you? Tan x is minus half. That means you're looking into two solutions which are in quadrant 2 and 4, correct? Tan x is negative in quadrant 2 and 4. What is the related acute angle alpha? When is tan x equals to half? Related acute angle alpha, which you normally write in books as beta, right? When is tan x equals to half? Use calculator. We actually did this question earlier. You remember 26 point something we got somewhere, right? Well, let's use a calculator and find tan inverse of half, right? So shift tan inverse of 0.5 is given to us as 26.5. Well, you're working in radians. So Samita, can you just change your calculator to radian mode and find the answer, please? Or
Yeah.
in degrees, it is 26.6. Okay. Yeah. And Samita, did you get? So in degrees, beta is 26.6 degrees. And Samita, how much did you get in radians? Change your mode to radians and find 10 inverse of half.
Okay, let me see. I'm getting in degrees.
No, change your, you have to change your mode. So every calculator has its own function. So change your mode to radians and then do shift tan inverse of zero point 0.5. Is that okay? And in radians, you will get your answer. Let me use a different thing as 0.46,
Yeah, I'm getting that as well.
right? So I'm just writing 0.46 and I could round it to 464. Is that okay? So that becomes your related acute angle. The two solutions are pi minus 0.464 and 2 pi minus 0.464. Is that clear to you? Those are your two solutions for the given equation. Does it make sense to you? Correct? So it's not difficult at all. So same principles as we did are to be followed to get these solutions. Correct? Akshat and Krisha, did you understand how do we solve these questions?
Yes, sir.
Yes, sir.
Here are some more complicated questions. So just take a picture of this particular page. Now what we have done is we have combined example 7 and 8 to get to example 9. We will solve the equation cos of 90 degrees minus 2 theta. Do you see? I made that 2 theta also component and x plus minus p equals to some value which is square root 3 over 2 within the interval 0 to 360 degrees. Okay. How do we solve this? Right. Well, take this as your question to solve as a homework, right? So I'll also upload the video. You will be in a position to check your answer. Of course, the first step is, cosine is positive in quadrant 1 and 4. You have to find the related acute angle, modify the domain as we have shown here, and get all the solutions, correct? Next question for you, which is the last question, is solution 10. Sine of 90 minus 2 theta is 0 0.5 within the interval 0 to 360. Find all possible solutions. Correct? So at this point, we are going to end our session for the day. Now, can you summarize what have you learned today? Akshay, did you learn anything today?
Of course, sir. Yeah, I learned a lot. I was indirectly introduced to radians and working with pi. And
Yeah,
I revisited how to work with trigonometric functions and the cast rule.
perfect. Krisha, how about you?
I learned new formulas on how to like find values of theta or alpha in a circle.
Correct. Samita, how about you?
I learned how to solve trigonometric equations as well as how to modify the domain when the argument is changed.
Perfect. And find all possible solutions. And also
Yeah.
remember, unit circle can only be used in very specific examples where, we have 30 degrees, 30, 60, 45 degrees as one of the solutions, or even 0 or 180, correct? But otherwise, we have to restrict ourselves, we'll have to use your calculator and find the answers, right? So at this early stage, you are looking into the unit circle, finding the solutions, but soon there will be questions as we discuss. Modifying the domain is a challenge most of the time to get the real solutions, right? I actually took very simple questions to introduce you to the concept, but I appreciate if you could do more questions from your book and challenge yourself, right? Okay. So we'll end our session here. All the best and thanks for sharing. Thank you. Have a great weekend. Bye.
Thank you, sir. Bye.
Also, I had a question for you,
Yes.
sir.
Mm.
Do you have any playlists like the ones I've sent you on the bottom, the inverse function
Yes, I
problem?
have. Yes, I have. Yes.
Okay. If you
In
can,
fact, yeah, I will actually share with you the inverse trigonometric ratios, right?
Mhm.
And, very good video, which will solve most of the questions which you shared with me.
Like the composite, like cos -1 of cot 5
Yes,
5.
sure. Actually, yeah, we don't have time today
Yeah.
to do it, but definitely, there is a very good. I'll share with you that uh,
Okay, sir.
after the lesson, and then if you have any questions based on that, ask me. Feel free to ask.
Mhm.
Okay, great.
Yeah.
Thank you. Then all the
Thank
best.
you. Bye.
Have a great day.
Bye. Thank you.
I